Okay, our bells are turned off today for AP testing, I believe. So we need to go ahead and get moving on this. So you guys picked up a ton of papers there this morning. All of these make up handout 115, and we are not going to finish all of this today. This is actually our work for today and for next Monday, so don't be overwhelmed by that. But go ahead and number them as 115, and you probably want to staple them together later, but if you haven't done that yet, then just go ahead and wait. Okay, the front page starts off with just 2 questions and then a great big box at the top. So the box is really where I'd like you to put all of our notes. So we're going to review the 3 things we talked about last class: holes, x-intercepts, and vertical asymptotes. But then we also need to talk about the other parts of rational functions and how to piece all of that together to get some graphs. And so we'll get through about 5 or 6 of these questions today and complete the notes. Now, on the notes, you guys are more than welcome. In fact, you're encouraged to reword these in a way that will click for you a little bit better. But the ones we talked about last class were things like x-intercept. These occur at x values that make only the numerator equal to 0. And I emphasized the word only a lot last class. We talked about vertical asymptotes occur for any x value or x values plural that make only the denominator equal to 0. And I emphasized the word only last class for that. And then the other one we talked about last time, so hopefully you feel okay with these so that we can focus on the other stuff, was how to find a hole. And holes were x values that make both the numerator and denominator 0. And the most important word in there is the both. Because if an x value is an x-intercept, it does not make sense for it to also be a hole or a vertical asymptote. Likewise, a hole couldn't be an x-intercept or a vertical asymptote. Visually, these can only be one thing at a time. So again, if you're not sure what to copy down on these, copy down what I have, and then at the end of class you can make adjustments. But we talked about these last time, so I'm not going to focus on them too much today. But before I show you the other parts that you need to know, let's go ahead and do these 3 parts for questions 1 and 2, and then throw all that information on the graph. So if you want to know what numbers make the numerator and denominator 0, I'm just going to do questions 1 and 2 at the same time. Sometimes that can be very quick, like on question 2, if it doesn't need to be factored. The numerator equals 0 at 2 and the denominator equals 0 at 4. Question 1, the numerator never equals 0, because 1 doesn't ever equal 0. There's no variable in there. But for the denominator, it's going to take a little bit more work. We need to factor, and it has a GCF and a trinomial, and you've got to do both of those so that you can set each part equal to 0. 3 doesn't equal 0, but x plus 3 does, and x minus 2 does. So each question is going to vary how much work it is. Question 2 is basically no work to figure that out. Question 1, we had to factor GCF and trinomial after that. But if we know which numbers make the numerator and denominator 0, any number that makes just the numerator 0, like 2 in question 2 is an x-intercept. If nothing makes the numerator 0, then it's not going to have an x-intercept like question 1. Now don't leave it blank, because that makes it look like you just didn't know and you left it blank. Say none or NA for not applicable. If there's any numbers that make just a denominator 0, like these two, they show up as vertical asymptotes, which are vertical lines, so we need x equals on each of those. In question 2, that would be x equals 4. And if there's any number that made the numerator and denominator 0, we would have whole. Bless you. But neither question 1 nor question 2 have whole. Now, this is part of why this handout's so big and why we will have to spend more than one class period on it. It's because, you know, to practice each of these things, you have to practice several questions. The first several questions may not even have a whole, so you may not even get to practice that for a few questions. A lot of these questions won't have a slant asymptote, so a lot of times you have to do several of them before you can even practice that one time. But these are the 3 that we had focused on last class. So let's throw these on a graph. Of course, points show up as a point. Asymptotes need to show up as dashed lines. So x equals 4, x equals 2, and x equals -3. Now, the asymptotes are actually going to be really helpful for our graph here in a minute. They help us quite a bit. Alright, so before we move on to some of the other parts, is there any part of that 3 you'd like me to go more in depth on, or any specific questions? Okay, then let's add to it. I think probably the easiest of all of these questions would be y-intercept. That's usually one of the first ones that I do. Just like all other algebra stuff, y-intercepts are when x equals 0. So plug 0 in for x and solve. Solve for y. Again, feel free to reword that in a different way if you'd like to. But copy that down, and then we'll answer that for question 1 and 2 and put it on the graph. Okay, so question 1, if I plug in 0 for x, I would get 1 over 0 plus 0 minus 18. So when x is 0, y is -1/18. So that is a point very close to the origin. And we might as well put the point in our little table here. And on question 2, plugging in 0 for x gives us -2 over -4, which reduces to 1/2. So we can plot the point 0, 1/2. So if you notice, I've already answered more than half of the questions about both of these, and I've had to do very little work. So I'm not saying that some of these won't take a bunch of work, but really the big hurdle in these questions is just knowing like what it's asking for and knowing the process, which is what we are hopefully going to be summarizing up here. Okay, next up, let's look at horizontal asymptotes. We actually reviewed this briefly during our limits unit because you need to understand horizontal asymptotes to do limits as x approaches infinity or negative infinity. But to do these, you need to compare the degrees of the numerator to the denominator. And then there's 3 things that could happen. the degree of the numerator could be bigger. The degree of the denominator could be bigger. Or they could be equal. 3 possibilities, that's why we have to memorize 3 rules. When the degree of the numerator is bigger, you don't have a horizontal asymptote. Degree of the denominator is bigger, it's y equals 0. And when they're equal, is when we did y equals leading coefficient of the numerator over leading coefficient of the denominator. Again, all that should sound familiar because we have even reviewed this year. But again, most of these take almost no work, but if you don't know what you're supposed to be checking for, if you don't have this definition memorized, then it's very hard to figure out. Okay, so question 1. Oh, sorry, I'll give you more time to copy that down. Okay, so question 1. The degree of the numerator is 0 because there's no x's. The degree of the denominator is 2. Since the degree of the denominator is bigger, it has a horizontal asymptote at y equals 0. Horizontal asymptote is an asymptote, which means we should graph it as a dashed line. It helps us get our graph. In question 1, the degree of the numerator and denominator are equal, so it's going to be y equals leading coefficient over leading coefficient, which is 1 over 1. So this guy has a horizontal asymptote at y equals 1. All asymptotes, graph them as dashed lines. Okay, domain we'll come back and do once we have the graphs completed, because domain's a lot easier to see when we see the whole graph. So one of the next to last thing we need to fill in on our notes in the top box is slant asymptote, which can be the biggest pain. But the good news is most questions don't have a slant asymptote. Now when I say slant asymptote, if you know what oblique asymptote is, it's the same thing. This is like one of those like global differences. Most of the times, like in America, we say slant asymptote, but most of the rest of the world calls them oblique asymptotes. Same thing. Okay, so this one's a pain. So first off, we want to know when it even has one, because most of the time we're just going to say that it doesn't have one. But the only time you're going to have a slant asymptote is when the degree of the numerator is 1 bigger than the degree of the denominator. So if that's not true, it doesn't have one, say none and move on. But if it does have one, if the degree of the numerator is 1 bigger than the degree of the denominator, how you go about finding that is we have to do long division, part of why we reviewed that recently, and it's going to be y equals whatever the quotient is. So if there's a remainder, we ignore it. Ignore remainder. Remainder has no effect on the slant asymptote. So let's look and see if questions 1 and 2 have a slant asymptote. I guess I can just slide this up. But question 1, the degree of the numerator is 0, degree of the denominator is 2, the degree of the numerator is not 1 bigger than the degree of the denominator, so this one does not have a slant asymptote. question 2. The degree of the numerator is not 1 bigger than the degree of the denominator, so question 2 does not have a slant asymptote. But to make sure that we practice this once together, I want to go ahead and move on to question 3 too, even though we haven't done the other parts. Question 3, the degree of the numerator is 1 bigger than the degree of the denominator. So this one does have a slant asymptote, so it takes 5 seconds of work to know that it has one, but then to know what the equation is, it's going to take us a couple minutes. We're going to have to do long division, and we have to know to not keep the remainder part of our answer. And to be fair, this long division question is a little bit messier than most, but it's okay. I'll talk you through it. It's messier just because it's going to have some fractions in it. Okay, so if we try to figure out what we can multiply by negative 3x squared to get positive 1x cubed, even with fractions, again, this doesn't happen very much. This isn't going to be like the majority of your test or anything. But if you break this up into 3 parts, I think it's much more manageable. This part needs to be negative because a negative times a negative gives me a positive, which is what I want. I know that I need another x because x times x gives me x cubed. And then what number can I multiply by 3 to get 1? 1/3. So it's a lot to do all that in one go, but if you do it in 3 pieces, negative times negative gives me the positive, 1/3 times 3 gives me 1, and x times x squared gives me x cubed. It's a lot more manageable. Okay, and then if we multiply it to this one, negative times negative is positive, 1/3 times 3 would be 1, and x times x would be x squared. Then negative 1/3 x times 18. So negative times positive is negative. Multiplying by 1/3 is the same as dividing by 3. So 1/3 times 18 would be 6, and x times no more x's would be x. Change the signs and add. And then it looks like we need to go one more time. So I can see I don't need any more x's because I've already got x squared and I want x squared. I can see that this next part needs to be positive. Positive times a negative gives me a negative. And then what number can I multiply by 3 to get 2? What number can I multiply by 3 to get 1? 1/3. Multiplying by 1/3 is like dividing by 3. So if multiplying by 1/3 gives me 1, and I want it to be 2, then I also want to multiply by 2, so 2/3. Okay, and then we got to multiply it by this stuff. Unfortunately, positive times a negative is negative. Timesing by 3, dividing by 3 cancel, so we get 2x. And then 2/3 times 18. This is like divide by 3 times by 2. So 18 divided by 3 would be 6, times 2 would be 12. Change the signs and add. And I usually start to get pretty quick here at the end of these question types because, again, slant asymptote, the remainder doesn't matter. So even if I made a mistake at the very, very end, I get lucky and it's not going to mess me up. The slant asymptote is going to come from y equals just what the quotient is. So again, kind of a pain, but it doesn't come up in many of the questions. Only when the degree of the numerator is 1 bigger than the degree of the denominator. But this is also an asymptote, so we should graph this as a dashed line. It's in mx plus b format, so we have an idea of what the y-intercept is. Use the slope, down 1, right 3. Asymptote, so dashed line, and that will help us out with our graph when we get to that one. So Of course, you don't want to do long division on every question when you really only need it in like 1 out of every 4 or 5. So make sure you know when to use it. Okay, let's go back to questions 1 and 2, and let's talk about the graphing piece, how to find the domain, and we'll write in a little bit of notes for domain. Actually, we can go ahead and do the domain right now, it's fine. So domain, just like all other times you've done this year, domain is a way to describe the x values of the function or his graph. It's a way to list out what x values make sense to plug in. So pretty much we just need to take out anything that's trying to divide by 0, which would be holes and vertical asymptotes. But since we've kind of already started our graphs on 1 and 2, we've got a little bit better of a visual here. So in question 1, I can see down here, I can't have x equals -3, which means I can have all of these values from the far left until x gets to -3. But then I have to skip -3 because that's division by 0. Doesn't matter if it's a whole division by 0 or vertical asymptote division by 0, I can't plug it in. Then I can hit all of these x values, which are -3 to 2. And then I can't plug in 2 because of division by 0. But then I can plug in all of these, which would be 2 to infinity. So I'm trying to color that down here below the graph to help you see what your domain should be. In question 2, the only thing that's division by 0 is x equals 4. So I can plug in everything to the left of 4, and then everything to the right of 4. Okay, and so the last thing we need is to finish off what these graphs look like. And sometimes, like question 2 is almost ready to go, whereas question 1 we probably need to put a touch more work into it. So we need 2 things to get these graphs. We need to know how our graph behaves around asymptotes, vertical asymptotes, horizontal asymptotes, and slant asymptotes. And sometimes you're going to need more points. So in question 1, I only know this 1 point, and that's just not going to cut it. I need at least 1 or 2 more points. So I'm not going to plug in. We're trying to do this without a calculator too, because if we wanted to know what the graph looked like and we had a calculator, we just graph it and be done. But I'm not going to plug 5 into this because 5 would be hard arithmetic. But I can maybe plug in 1, doesn't look too bad. If I plug in 1, it's going to look like this and give me -1/18 again. So same y value as x equals 0. Oh wait, that's not right. This would be -1/12, sorry. My arithmetic's off. So actually, that's also almost 0, but it's a little bit bigger than -1/18, not much. And I would probably also recommend maybe plugging in like -1. Now, if you're ever unsure if you should plug in more points, you probably should plug in more points. It's going to make your graph look better, and it'll help you catch some of your work, some of your errors. So if I plug in -1, it's going to look like this, and that is -1/18. So these two are the same. This one's a touch bigger. Not much, but a little bit. Okay, now we have enough information to actually graph both questions 1 and 2, but you need to make sure you're paying attention here because it's going to go really quickly. We don't need more points. The way your graph will behave around vertical asymptotes is this is when we get those vertical spikes in the graph. So it's either going to shoot up to infinity on one side and then down to negative infinity on the other side. But sometimes it shoots to infinity on the left, sometimes it shoots to negative infinity on the left, sometimes it shoots to positive infinity on the right, sometimes it shoots to negative infinity on the right. So this is where these points, even though it seems like, you know, who cares, it makes a big difference, because I know from here to here, this one's going down, although very not much, but it is going down a little bit. And then based on the direction of this graph, it must keep going down, which means that it goes to negative infinity on this side of the asymptote and positive infinity on the right side of the asymptote. Likewise, based on my direction here, I can see that this is going to shoot down to negative infinity on the right, which means it's going to shoot up to positive infinity on the left. And again, it's not a bad idea to plug in x equals 3, x equals 4, x equals 5, x equals negative 4, x equals negative 5. They're going to be harder to compute. But that's how your graph is going to interact around vertical asymptotes. The way your graph is going to interact around horizontal and slant asymptotes is those tell you what your graph approaches as x gets really big, it approaches that line, and as x gets really small, it approaches that line. And then now we've got the graph. So that would be all we needed there. Question number 2, I don't think we even need more points, because if we know these 2 points from the x and y intercepts we had to answer, and they're connected, I can see based on the shape of this graph, the direction of the graph, that he's going down. So he's got to shoot down to negative infinity on this side, which means he's shooting up to positive infinity on this side. And the way your graph behaves at the far left and far right of a horizontal or slant asymptote is that's what it approaches on the left, and that's what it approaches on the right. Now, if you didn't feel very confident, again, you could plug in more x values to make sure that they are around what the rest of the graph looks like. But those asymptotes give us a lot of directions about which way we should be heading, so that helps us fill in those gaps pretty quickly. Okay, let's go through all of question 3. You just follow along with me again, and we'll finish up question 3, graph it all, and then with question 4, I will slowly have you start some guided practice where you try them first. So we already did the real pain in question 3, which was the slant asymptote, and we graphed it as a dashed line. It's an mx plus b format. We got that done. Now, when I ask you to do question 4 in just a second, what you should do is start off with the ones you're most comfortable with. There's no order to this, just whatever you think is easiest. What I think is easiest is y-intercept, because you just plug in 0 for x and you solve. 0 minus 0 minus 0 divided by 0 minus 0 over 18. 0 over 18 is 0. Plugging in 0 for x makes most stuff go away, so that's a nice and easy one. That's a point. Put it on your graph. On your test, if we say you have to make a table with a certain number of points, might as well put it in the table. It's a freebie. Okay, for x-intercepts, holes, and vertical asymptotes, I have to think about what numbers make the numerator 0 and what numbers make the denominator 0. So for the numerator, it looks like I could factor out a GCF and factor the trinomial so that I can see 0, 3, and negative 2 make the numerator 0. The denominator also has a GCF and a trinomial. Again, you don't have to factor as quickly as me, but when you factor some, you need to make sure that you're factoring it correctly, otherwise it's going to cause a lot of confusion. Negative 3 never equals 0, but x plus 3 equals 0, and x minus 2 equals 0. And so numbers that make just the denominator 0 are vertical asymptotes, vertical lines, so you need the x equals. And since they're an asymptote, we can graph them as dashed lines. As you saw from questions 1 and 2, it actually helps us quite a bit with the graph. Any numbers that make just the numerator 0 show up as x-intercepts, and there's 3 of them: 0, 3, and -2. By the way, 0 shouldn't have been a surprise, because the origin is not just a y-intercept, the origin is also an x-intercept. So we really kind of knew that one already. But if we needed a table, there's 2 more free points. Put those points on your graph. Horizontal asymptotes, we have to compare the degree of the numerator to the degree of the denominator. When the denominator is bigger, it's y equals 0. When the degrees are equal, it's leading coefficient over leading coefficient. And when the degree of the numerator is bigger, then you don't have one. By the way, if you look carefully at the definition of horizontal asymptote and slant asymptote, you should see why that you can't have both of those. If you have a slant, you can't have a horizontal. If you have a horizontal, you couldn't have a slant. Oh, holes. I don't know how I skip holes. Holes would be any number that makes the numerator and denominator 0. So in this case, none of those matched up. And again, this is why you have to practice so many questions. We have almost 3 questions under our belt today, and we haven't got to practice finding the hole once yet. So, okay, and then domain's a lot easier to do after your graph is finished, so let's just go ahead and wait on that. So we have some points, we've got some asymptotes, we know how it behaves around the asymptotes. You're always welcome to get more points. Sometimes you need to get more points, like question 1, for you to know the direction of the graph. Sometimes you don't, like question 2. But on this one, I would say, I don't know, why don't we try to plug in x equals 1? Just try to figure out one more point. If you're never sure, then you just got to plug them in and see. But if I plug in 1, I would get 1 minus 1 minus 6 over -3 minus 3 plus 18. -6 over 12, which is -1/2. Nothing special about x equals 1 other than I figured I could do it without a calculator. Now 1 point's making a big difference here. Now I'm pretty confident in what's going on in my graph. So again, if you tune out here for a second, you're going to glance back up, but it's going to be finished. I know it's going through these 2 points, so I know they're connected. I can see from left to right the graph is going down, and the way it has to go with this asymptote is it's either got to go to infinity or negative infinity. So based on this direction, it's going to negative infinity. If it's going to negative infinity on the left, it's going to positive infinity on the right, which is good because it's supposed to hit this point. If something's wrong, usually there's something that seems confusing and inconsistent. Okay, from here to here, it looks like it's going up, so it's going up some, but then it turns back around to hit this point. And based on this direction, it must be going to negative infinity on the right and positive infinity on the left. And then just like horizontal asymptotes tell you what its approach is at the end of the graph, slant asymptotes do the exact same thing. This line gets closer and closer to the slant asymptote on the far left and the far right. So any extra points that you did would just give you a little bit more confidence, maybe a tiny bit more accurate graph, but it should look pretty good. Okay, and let's go ahead and fill in the domain now, and then I want to talk about the graph for a second, and then I'm going to give you a few minutes to try question 4. Okay, now that we've got the graph in front of us, I can see it hits all of these x values, which would be negative infinity to negative 3. Then it hits all of these x values, which is negative 3 to 2. And then finally all of these x values, which would be 2 to infinity. Again, I'm trying to color those different intervals to help you see where those parts of the answer are coming from. Okay. I need to cheat to see the function here for a second. I don't have a hard copy, but what I'm going to do is I'm going to graph this in my calculator, which normally I would make you guys do, but my classroom calculators are gone today. They have to take them up for AP testing. Okay, so when I graph this, I've also changed my window settings from -5 to 5 and -5 to 5, just like your graph on your paper. But if we did something wrong, it should be pretty obvious, but it also gives us a good little hint about what we did wrong. So this, at a quick glance, compared to this, I would say those are a pretty good match. You agree that those look close enough for how much time we spent on it? Obviously, plotting a lot of points would be even better. But one extra thing I could do, I didn't think to say this to my last class, but this compared to this, that's what we were trying to analyze and figure out. So this slant asymptote, you can kind of see it in here, but when you're working with your calculator, now we won't let you have a calculator on the test because you could just graph it and not know anything. We need to see what you know. What did we say the equation of the slant asymptote was?
Negative 1/3 x plus 2/3.
Negative 1/3 x plus 2/3. When you check with the calculator, there's nothing stopping you from also graphing this, and it's good for you to see that slant asymptote is like a perfect little fit here. It approaches it on the far right, and it's approaching it on the far left. It just fits in just perfectly. Okay, so what I would suggest you do is to maybe take just a moment or two and see if there's any of these definitions that you would like to elaborate, reword, squeeze an example in. This big box here is really for you. Like, I mean, I expect you to have something down for your homework points, but I want it to be worded in a way that makes sense to you. Then take about 5 minutes to try question 4 and start off with the ones that you feel most confident about, that you don't feel like you need your notes for. Do those first. Then try the ones that you're less confident with. And then when you get to the ones that you're not confident with, read your notes in the box before you try it. But as we work through each of these questions, and as each time you practice another one, you should feel like you're referring to your notes less and less. That repetition will help you memorize all that stuff in that box. But I'll set a timer, and in 6 minutes, I'm going to go over it. And to be honest with you, it might be hard for you to do all of this one in 6 minutes, but it's good for you to see what stuff is clicking and what stuff you need to actually review. that has been 6 minutes already. So again, I realize that may not be enough time the first time, but as you do these, you should be referring to your notes less, and they should be feeling easier and quicker. So which one you started with, it's just going to change by each person, but at some point, y-intercept is probably the one I think is the easiest. So if you tried to plug in 0 for all the x's, you got -6 over -12, which is 1/2. So when we start to put the graph together, we've got 1 point, which is good because you've seen that you don't really need 1,000,000 points to be able to graph these things. So any point we get is very appreciated. Okay, all 3 of these you can knock out if you can figure out what numbers make the numerator 0, which is easiest to get from factoring. Looks like 2 and -3. And what numbers make the denominator 0? The denominator had a GCF and a trinomial. If you don't factor out that GCF, it's a lot harder to factor. And then we have to know the definition of these, of how to find these. So -1 makes only the denominator 0, so that's a vertical asymptote. 2 makes only the numerator 0, so our only x-intercept should be 2. And numbers that make both the numerator and denominator 0 are the x value of the whole. Now the y value, we haven't reviewed this today, but we talked about this last time. You have to plug in the x value of the whole into the reduced fraction. So not into the original fraction, not into this factored numerator over denominator. You need to cancel out these factors that match up and then plug it into what's left over. So on top, that would be -3 minus 2, and on bottom it would be -4 times -3 plus 1. So it looks like -5/8. Now if we put all of this stuff on our graph, of course 2, 0, x-intercept is just a point. X equals -1 is an asymptote. So dashed line. And you might not think that the whole is very helpful, but it will be. And when we graph it, we need to show it as an open circle. So when x is -3, -5/8 is about right there. So open circle there. Alright, at some points you need to do horizontal asymptote. So compare the degrees, and since they were equal, it's going to be leading coefficient over leading coefficient. Y equals -1/4. And then this is where, you got to be able to compare these fractions a little bit. -5/8 is less than -1/4, so it should be below it. If you put it above it, it's going to be confusing with your graph. Because the degree of the numerator is not 1 bigger than the degree of the denominator, it doesn't have the slant asymptote. If it did, we'd have to do long division and keep the quotient only. And then the domain I'll come back to. But we actually sometimes need more points. You're always encouraged to do more points, but I think we have enough in this question. I think we have enough because we know these two are connected. Based on the direction of this line, I can see it's going to infinity on the right side of the vertical asymptote, so -infinity on the left side of the vertical asymptote. Even though it doesn't hit here at this spot, it doesn't hit the hole, it is going to hit the points right before it and right after it. So that helps me with that. And then the slant asymptote and the horizontal asymptote tells you what your graph is approaching on the far right and far left of the graph. And of course, if you had a calculator or you pulled it up in Desmos, I guess, it's going to look pretty good. You're not going to be able to see the hole on the graph probably. Calculator tries to do that sometimes, but it doesn't do a great job. Now with the domain, be careful. This is not in your domain. Notice when x is -3, there is no y value. So our domain is -infinity to -3. That'd be all of this stuff. Then -3 to -1. And then -1 forever to the right. So that would be our domain. I'll copy that up to above. So it's okay if I didn't give you quite enough time, because again, you should get quicker at each of these. And if you're starting with the ones you're most comfortable with, you are starting to realize which ones you may not know the definitions too well enough and what you're slowing down on. Okay, do y'all have any parts of number 4? Any questions on number 4 you'd like to ask before we reset and do it again? Okay, then let me give you a few minutes to try question 5. I will give you a hint here on 5 just because I don't want you to mess up your whole graph. There is a negative out here, so you should probably just put that negative next to 4 and then cover that one up. If you forget that negative the whole time, your graph is going to be upside down. So same idea. Start off with the easiest ones. If you really know them, those blanks shouldn't take you that long. Then the ones that you're less comfortable with, try them without the notes at first, but then lean on your notes as needed. Oh, just so I don't forget, remember that advisory today is at the end of class. It's not after this class for the moving up ceremony. So don't go to advisory after this class. Go straight to third period. So that's been almost 9 minutes. So I feel like you should feel like you're closer to finishing that one. So as a quick check, here's what the graph should look like. So if your graph looks very similar to that, then that's a good sign. And if your graph looks wildly different, then we need to see what parts you didn't consider and what might have gone wrong. Okay, but if you've got basically that graph, you're probably fine, and you can tune us out and move on at your own pace. So this one, if I try to plug in 0 for x and solve, you get -4 divided by 0, which doesn't make sense. You can't do. So that means there's no y-intercept, which is why the graph never crossed a y-axis. Thinking about what numbers make the numerator 0. -4 never equals 0. And what numbers make the denominator 0? 0 and 3 gives me these three. There's two numbers that make just a denominator 0, which is why there was 2 vertical asymptotes. There's no numbers that make just a numerator 0, so there's no x-intercepts. And there's no number that makes the numerator and denominator 0, so there's no holes. Now that's kind of unfortunate because again, some of these points really help us out with the graph, but it is what it is. The degree of the denominator is bigger than the degree of the numerator, so that tells me the horizontal asymptote is y equals 0, and it tells me that there's not a slant asymptote. To have a slant asymptote, the degree of the numerator has to be 1 bigger than the degree of the denominator. And so really from all of this, all I get is a couple lines. X equals 0, x equals 3, and y equals 0. Now that's not enough to graph your equation, so we need some more points. So again, sometimes you don't need them, sometimes you do. But I would try maybe plugging in 1 into the function, and you end up with -4 over -2, or 2. So 1, 2 is a point. Could try plugging in 2. And you get 2 again. Maybe try -1. You get -1. And you can keep on going if you want to, but for me I have enough points because I can see what's going to happen now. If this point's down here in the bottom left and this point's up here in the top right, this must be going to -infinity on the left, so +infinity on the right. That's the only way that I'm going to hit those 2 points. This graph is going down, so it's going to keep going down, but I also figured out this point, so I know it turns around pretty quickly. And so then it's going up on this side and down on this side. And because it has a horizontal asymptote, I know it's going to approach that on the far left and approach that on the far right. So I defined a couple more points to help me out, but a few points and knowing how it interacts around those asymptotes, everything kind of falls into place pretty quickly. And now that I've got that down, I can answer domain pretty easily. It hits all of these x values from -infinity to 0. Then it hits the x values from 0 to 3. And then it hits all the x values from 3 to infinity. Okay, I would like you to do just one more of these, please. And we are on a different bell schedule today. However, you guys still have 10 minutes. So in 10 minutes, if you would please try question 6 to the best of your ability. And if you can't finish that in 10 minutes, please make sure you spend a few minutes for homework. But also, maybe more importantly, this box on the top page, while all of this stuff is fresh in your head, again, some of this you might want to reword. Some of it you might want to give examples to. Some of it you might want to be more detailed. That's really there for you. I don't care how you describe domain as long as it helps you answer domain questions right. So if you wait till Monday, you're going to forget which of these are not as clear to you. So consider updating those as well while you're here. So at least do one more, question 6. You're obviously encouraged to do more than that, but just to be clear, you don't have to do all of these questions. We have all of Monday to practice them again. guys have just a minute with this different schedule, so you need to find a stopping place